Bismillahirrahmanirrahim. Assalamu Alaikum, dear student. Welcome to my YouTube channel Learn with Azam. Today we will discuss about new syllabus 6 SST to National Book Foundation unit number 11 sound. Today we will discuss SLO base according to FBISC requirement exercise chart questions or also called conceptual chart questions. Now today we will discuss question number 1 to 6 in part 1. Now we will start the conceptual chart question of exercise. Question number 1. Why does sound travel fast in solid than liquid and gases? First of all, sound travels more quickly through a solid and through a liquid and gases because the molecule of solid are close together and there can be transmitted the vibration energy faster. Here, one thing is important in this paragraph. The molecule of solid are close together and they can transmit the vibration energy faster because they have a strong intermolecular forces. Due to the strong intermolecular forces, the energy is transferred very fast as compared to liquid and gases. Sound travels most slowly through a gas because the molecule of gas are farthest apart. So they have less intermolecular forces as compared to liquid and solid. Since we can give an other answer, solid is nothing more than a local disturbance whose propagation is facilitated by oscillation between the particles. Now this disturbance propagates in a longitudinal wave. Imagine one molecule hitting the next molecule and the molecule hitting the next molecule and so further. The distance between the molecules in solid are very small. Here simply we can say that they have strong intermolecular forces as compared to liquid and gases. So the force of sound can faster as compared to liquid and gases. Here we can add one more thing. If in a gas particle, sound is travel. The speed of sound in a liquid is 5 times more than as compared to the gases. And we can also say that in a solid object, sound travels faster 15 to 17 times as compared to the liquid. More, we can read that solids are dense and compressed to the liquid and gases because they are also close. They can be collide very quickly. Takes less time for a molecule of solid bump into the neighborhood. So we can also say that solid are packed together tighter than liquid and gases. Hence solid travel faster in solid. So sound is very fast travel in a solid. The distance in a liquid are shorter in a gases but longer than solid. Liquid are denser than gases but less than solid. So solid is sound is travel second faster in a liquid and gases are slowest because they are least denser. The molecule in a gases are very apart compared as a solid and liquid. So we can say that and also define that in a gaseous state sound can be traveled very slow and in a solid 5 times to 9 times greater than as compared to gases, and in solid 15 to 17 times faster as compared to the gases. Now we can also another answer, sound wave travel faster in solid because solid are the most dense state of matter. Here solid wave travel by vibrating particle, they clear the particle or each other. They are easier it is the far to bump to each other and they pass in on the vibration. So gas particles are like air are very separated out. As such as its particles have longer to travel between each other past the vibration. Water particles are strongly closer than to each other, mean it takes even less time than transmit a vibration. So finally particles of solid are locked to each other by side, nearly touching to each other, meaning that the passage of sound vibrating between them it is nearly intensely. So it is clear that here we can read the three answer of one question. Now question number 2 is given statement. Why are we able to distinguish between two sounds having the same loudness? So it is clear that sound have same loudness will be same amplitude and same pitch, and also we can say that have a same frequency. So quality help to distinguish between the sound wave having the same loudness and same pitch. So here we can say that pitch is distinguishing between the two sound of same loudness and timbre. So the this scene of that we can say that pitch is the one of the quality that is difference between the two sounds. So frequency is commonly referred to as a pitch because we also defined that frequency is directly proportional to pitch. Here we can write that frequency is directly proportional to pitch. Higher the frequency, higher the pitch, which means shrill sound have and lower frequency is the lower pitch, which means that flat sound. So, hence the quality or timbre of sound is the characteristics which is unable to us discerning one sound from another having the same pitch and loudness. Now we can also say that another answer, the difference between the sound are caused by the intensity, pitch and tone. So sound is the wave and wave have an amplitude or height. That amplitude is measure of energy. The more energy of a wave have, higher its amplitude. So we can say that two sound have same loudness and same pitch produced by different instruments differ to each other different waveforms. So the waveforms depend on the number of the subsidiary nodes and their relative amplitude along the principal node. Here we can write two answers. It means both are related to the question number 2. Now we will discuss the question number 3. In question number 3, given statement, vibrating mobile phone is on wooden table, sound louder than held in our hand. Why? So we can write the answer, hard denser surface like wood decks reflect the sound more than as a soft surface like our bed. Well, the phone is only vibrating, the phone itself makes the sound from the vibration mechanism and connect with the surface it's on it. Now your bed is likely to produce less sound via the phone physically moving on the surface and will also observe more of sound from the phone itself. So we can write that the vibrating tuning force is the table top to the vibrate. Now we can say that the tabletop has much larger area and it's therefore it connects with the large volume of air undergoes the vibration. Hence the sound here is louder. It is clear that now we will move question number 4. In question number 4, during a match, a cricket stadium, you see the batsman sticking the ball, but where hair stroke sounds slightly later. Explain this time difference. Now, there is a large difference in speed of sound that of light. It is because the light speed is 3 multiplied by 10 raised to power 8 meter per second is greater than the speed of sound in air 340 meters per second. The prospect watching the cricket game hears the sound of stroke. A little later than the batsman is seen actually making it. Now, spectators watching a game of a cricket hear the sound a spell of second after the batsman make a stroke. The spectator watching the game hear the sound of after some time because the sound travel at the speed of 340 meters per second in air. Now, therefore, it is make some time of sound to reach the spectator sitting in the stadium. Now, we will move the question number 5. In question number 5, given statement is that how much intensity level is increased. When intensity of louder sound is double, then the intensity of faintest sound of audible sound. Now, here first of all, sound of level beta 1 that is equal to beta 1 is equal to 10 log of I over I naught. Here I naught is the constant and difference of intensity. Now when the intensity is double, the sound level will be beta 2 that is equal to 10 log 2 I naught divided by I 2I divided by I naught. Here we can difference between them beta 2 minus beta 1 that is equal to 10 log of 2I naught over I. So this is the difference between the two intensity levels. I cancel out by I, then 10 log of 2. Taking the log 2 that is equal to 0.3010. 10 multiplied by 0.3010 that is equal to 3 decibel. Thus the sound level is increased by 3 decibel. Now the answer is another. We can also say that be careful with the decibel scale. It is had asked about the doubling the sound intensity. A clear answer is would be have given possible and relevant. The answer would be have be 3 decibel. Now we can doubling the sound intensity level is usual and there is no real answer to the question. There is no single number of the restriction to change the intensity. So we can say that the sound intensity in question number 6, two singers are sitting together simultaneously with intensity level is 60 decibel of each in hall. Now in first part, if the intensity of sound in the hall is double and B is the intensity level of sound is double. First of all, we answer the first part. Sound level beta 1 is equal to beta 1, that is equal to 10 log of I over I naught. Here I naught is a constant reference intensity, and here when the intensity is double, then beta 2 is equal to 10 log of 2I over I naught. Taking the difference of both quantity beta 2 minus beta 1, that is equal to 10 log of 2I over I. I cancel out by I, then taking the log 2. Log 2 is equal to beta 1 minus beta 2, that is equal to 10 multiplied by 0.3010, that is equal to 3 decibel. We can say that thus the sound level is increased by 3 decibel. And other answer, we can also write that decibel are not like a measuring tape. If adding one to another or previous setup like walking, then we have no. For starts, the decibel is logarithm. Every 3 decibel increase means a doubling of acoustic power, regardless of where on the scale you are. It takes a 10 decibel increasing for nothing to for thing to sound is twice as louder to our ear through it. Now, we can also say that if you have two sound sources that are identically in every way, they will combine to 3 decibel louder. If your example is mean that a combining of the volume of 363 decibel, if the sound sources are not identical, they will be combined and interference at the different frequencies, meaning the net result could be anywhere from 1 to 2 decibel louder, to even 1 to 2 decibel quieter if the sound is interference from to each other. Now, answer of second part, intensity in a physical property of sound. It is measured by observing its effect on the physical instrument and described numerically. So we can explain that it is the same whether the anyone listening to the sound or not. Loudness is a subjective and perception of intensity. In other words, impressive of the sound make on the listener. Loudness is not measured physically, but it is described in words such as soft or loud, can barely hear you, or increasability of sound. Different people listening to the same sound may be described it the loudness differ. A hearing is improved the person, for example, may be judged at a certain sound how to loudness. Well, in normal hearing of person listening to the same sound may be judged it is to be loud. Loudness is an increase when the intensity is increased, but non-linearly, because loudness depends upon its complex way of several properties of sound. That is intensity, such the sound of the frequency and vibration with the time. It is clear that inshallah in next video with next lesson. Best of luck.